Thank you, June. So as June mentioned, my name is Strey. I am a principal engineer at Target. You can follow me on Twitter at Strey203. For the most part, I tweet about tech. Unless I've had a few beers, you might see some politics if I caught the right thing on the news. So to start, I want to talk a little bit, and the title's Simplifying Omnichannel at Retail, and I'll touch on more about what that actually means in a little bit. But to begin, I wanted to talk about some of the core use cases of Kafka at Target, and I think we're using Kafka for a lot of what pretty typical high-volume use cases that you see a lot of companies using Kafka for. So things like log aggregation, threat detection, and Target.com's clickstream. But the focus of the talk is really going to be on how we're using it for business event messaging. So how we're using it to enable real-time business process by reacting to things at the moment that they happen. So to start, I want to give you a little business context about the sort of problems we're solving with Kafka at Target. And I want to start there for a few reasons. One, to highlight the critical role that Kafka and the ecosystem around it is playing in our technology landscape. Two, to highlight the transformational impact a stream data platform can have on an organization. And three, because we are hiring, and hopefully you find these types of problems that we're solving interesting and want to come and chat with me or Randy Klingman, who's here on my team today. So just a little bit about Target. 1,806 stores across the United States, 38 distribution centers in the United States, 323,000 team members worldwide, global locations in India. And we have Target.com, that is the fourth most visited retail website in the United States, with more than 26 million unique visitors each month. So the title of the talk is Simplifying Omnichannel Retail at Scale. And omnichannel in itself is a bit of a loaded word. And I think depending on who you ask across the industry, the definition changes. So I want to talk a little bit about what the word omnichannel means to me and how that has evolved over time. So if you appreciate the history of retail, you'll understand that brick and mortar shops initially stood up e-commerce capabilities that were completely distinct from the systems that run their brick and mortar operations. And so in those two systems, items might have different taxonomies, they might have different promotional models, they might have different identifiers. And what Omnichannel Retail meant to me for that first iteration was providing a unified view through microservices of those two views of what an item was and how it was classified and how promotions were managed. But it's taken on, so after we did that, we realized that doesn't really matter. If it still takes you 5 days to ship a pair of socks to somebody, great, you provide a unified view through your digital channels, but you're still not going to win the game until you start to leverage all of your assets from the ground up in a truly sort of omnichannel way. And I'll talk a little bit about what that means through the context of our supply chain. So to put it bluntly, and this was pulled directly from our COO's deck after our 2016 fiscal year results. To put it bluntly, we're slow and we have too much inventory. And this used to be a very difficult thing for us to admit as a company. But it is something that is easy for us to admit now because we're doing something about it. And in the past, our supply chain moved products in case packs. Product was shipped in case packs, products was replenished in case packs, and products was moved throughout the store in case packs. And the systems that managed that supply chain were built in batches because the product moved in batches. Now, a portion of the supply chain will always move in batches, but to manage the growing demand and change the way we replenish a product in our store, we realize we have to start moving product in eaches. And the concept is really quite simple. You know, we sell one, we replenish one. We have systems in place today. When a register rings at a Target store, we can have a transporter cut in a distribution center and the wheels in motion to put an item on a truck within seconds. And that truck will arrive at that store with that item replenished within 24 hours. And when we move with that much speed and that much precision, in-stocks go down, or out-of-stocks go down, excuse me. So the amount of time you show up to the store and we don't have something you're looking for, safety stock goes down. So the amount of extra stuff we have to keep in the store to ensure that in-stocks or out-of-stocks stay down. And our speed goes up. And we end up with a store that has zero inventory in the back room, which is actually a pretty powerful thing. Not only is there zero inventory in the back room, there's less inventory on the sales floor of that store. So we've freed up a lot of additional space in our stores. So what do you do with all that extra space now that you have this capability? You could do things like add store experiences or use your stores as mini fulfillment centers close to the guest to help win the lead time to delivery game. So by changing the way we replenish our product to think about it as a stream of product built on a streaming platform, we significantly increase our organizational agility. And here's the kicker. 85% of our demand is within 10 miles of a target store. So think about that. That same pair of socks that I said, great, we provided an omnichannel view from a system standpoint to the guests through our digital channels. Now we've rethought the way we leverage our supply chain and our stores. And then we can really start to compete in the omnichannel game because we can get you that same pair of socks potentially in the same day or in the same hour. So that really has the power to change the way we do things at Target. So to what this means tech-wise and why I'm here at Kafka Summit, I think it's pretty obvious how the applications of Apache Kafka sort of enabled all of that business transformation. And I think the technical merits that Kafka brings to the table has already been talked about quite thoroughly today. But I want to give a little bit more of a personal story about sort of how my relationship with Kafka began. So it came when we were starting that first sort of organizational effort towards becoming omnichannel, so unifying those .com and those store systems. So we were building out the microservice that provided product information through our digital channels. And the hardest thing about that effort was not designing the HTTP interface or implementing the logic to query that data from a forward cache. It was pulling the data from the source systems and getting them into that forward cache. So I was yet another person in the organization that had to go through all of the effort to figure out how to query that data from source, at what interval I wanted to do it, and implement the error handling logic to get it there. And that was just mind-boggling to me that I was the 15th person in the organization that wanted item data changes and had to go implement everything myself. So it was at that point I was sort of convinced that we had to do something about it as an organization. So me and a few of the rest of us that were solving similar problems throughout the organization actually got together at an offsite at the University of St. Thomas in Minneapolis, and we invited June and Jay to town. And over the course of those 2 days, we decided that we were going to implement a true stream data platform as an enterprise offering for the organization. So we didn't run into these scenarios anymore down the road. So now into a little bit of the technical bits and the stories from the front line. So our implementation is pretty straightforward. We're running across various data centers, including those run by Target or owned by Target, and a couple of public cloud providers. And the overwhelming majority of our core systems reside in our data center. So we're using Mirror Maker, and we are also looking at alternatives to Mirror Maker, but to mirror data from those core systems out to the cloud, where guest-facing systems are serving that data up. And what makes our deployment unique? There's quite a few things. I think one of the biggest ones is that we have up to 300 topics per cluster and growing. We had a day last week where we provisioned 15 topics in a day on one of our clusters, and we're starting to hit that theoretical limit of where Kafka has been tested for the number of partitions for a given node. We have one large enterprise cluster for business event messaging, and occasionally we spin off a shared cluster or an isolated cluster for various reasons. Kafka Streams is becoming more and more a technology that people are talking about. We recently upgraded our environments to 0.10, and teams are beginning to ask about streams as a mechanism to do stateful stream processing and replace some stateless services with stateful services. We do 10 to 20K fetch consumer requests per second, and I'll talk about some of the reasons why this is the case in a little bit. Exactly one semantics is a need, and I think, as we all know too, that it's not a capability that's provided today, but a capability that's coming soon with Kafka alone. We are deploying clusters in the cloud and moving to deploying clusters in our data centers immutably. Compaction is a widely used feature across our organization. And then the diversity of clients, given that we have 300 plus topics per cluster, that's a lot of clients. So the diversity of clients in our environment is pretty vast. We're using SSL for authentication and authorization across our environments. We take an approach of SSL first, plain text only if there's a legitimate good reason that you need it, and then providing an end-to-end audit capability for people leveraging the cluster. So immutable deployments, and we're actually not truly immutable today. I would call it semi-immutable, I guess, in our cloud environments. So when we spin up our clusters, we use Spinnaker for packaging and deployment, and Spinnaker is nice because it provides a layer of abstraction across various cloud environments. So we can deploy to public cloud provider 1 or public cloud provider 2 or our internal OpenStack using the same packaging and deployment mechanism. And I say semi-immutable because we aren't truly, if we're making a small configuration change on the cluster, like or changing the number of network threads or the number of IO threads, we're not actually sending out a new image because we're using ephemeral instance storage for the data directory. So we're not actually spinning up a new one for that instance, doing a partition reassignment, and then taking down the old one. We're externalizing config like that has a potential to change frequently to console. So console is just a key value store, and we use console templates. So it's not truly immutable in the sense that every little change is an immutable thing. It is semi-immutable. The other unique thing is, as I mentioned, we get 10 to 20K fetch consumer requests per second on some of our clusters. And there are legitimate reasons for that and illegitimate reasons for that. And I shouldn't say illegitimate. There are good reasons and bad reasons. The good reasons are that we have 1,800 stores and 40, 50 distribution centers. So that's a lot of potential producers and consumers for any given topic, right? When you have a multiplier of about 2,000, if all of a sudden the distribution centers and stores care about consuming a topic, that is a pretty significant magnifier in those cases. So architecturally, we've segmented our clusters and created what we call our stores cluster. So anytime there's the potential for that sort of multiplying factor, or that 1,800 multiplier, that data will flow through that stores cluster to try to isolate the other tenants. And then there's some bad reasons that we have that high number of fetch consumer requests per second. And the bad reasons are overwhelmingly poorly configured clients. They're overtuning for latency. There was a specific bug in a version of Storm that was widely used across the organization that defaults the fetch min bytes to 0 on the Kafka spout, which is a terrible thing when there's no data coming through on a topic, because essentially what the client or the clients do is sit there and they denial of service the cluster with fetch requests. And because they're Storm clusters, there's a lot of other things running on there, so you can't just go ahead and blacklist that IP from consuming. So that's put us in a bit of a pinch a number of times. And I mentioned that compaction is a widely used feature. And when the feature came out, I was one of the people in the organization pushing it. I thought conceptually it was extremely powerful. At the time, we were running 0.8, though, and we quickly realized that there are two pretty significant bugs with compaction on 0.8, and that happens to be the fact that if you publish a compressed message or an unkeyed message, the log cleaner breaks. And the fact that that log cleaner is a shared resource across the cluster, it's the same thing that's compacting the consumer offset topic. The fact that if anybody sitting on their local laptop, because there wasn't security in .8 either, could fat finger something and push a compressed or unkeyed message to a compacted topic, we found ourselves spending a lot of time manually fixing the log cleaner. The same was true in .9. Now, the bugs fell far more into the edge case category, but we still found ourselves spending, once every other week, we'd hit one of those edge cases, and we'd be manually going in and playing with the log cleaner offset checkpoint file to try to fix the log cleaner so it would continue to run for the rest of the cluster. The good news is we're now on version .10, have been for, 2 months? The log cleaner has not broken once since we've upgraded to .10, so it appears every bug that we've ran into at 0.10 has been fixed, at least so far. But still, the feature, that shouldn't deter you from using the feature. I mean, the merits of it are still fantastic. It's just a cautionary tale, if you will, depending on what version you're running on. And then, given the number of clients in our environment, when you have a poorly configured producer or consumer or a rogue client, it's necessary to be able to troubleshoot and identify who those peoples are in the event there's a stability issue on the cluster. So let's say we have a rogue consumer. Somebody's configured to fetch min bytes equals 0. We need a mechanism to enable visibility into who's doing what and when. Now, the request logger is a potential option, but we've noticed that when we turn on the request logger full-blown, it has a detrimental impact on the health of the cluster. So what we're working on right now is a way to either sample or tap the request logger to provide some level of insight that isn't as invasive to cluster health as just enabling it full stop is. And we've talked about this a little bit. I think I was in one of the streams sessions earlier today talking about the exactly one semantics feature was mentioned, and we have, and one of those use cases was like finance. So we have use cases like finance where we need exactly once would be nice, but today we at least need at least once, which Kafka guarantees. But in addition to that, finance might be subject to something like Sarbanes-Oxley. So they may need to prove that they have a control in place, whether it be SOX or some other regulatory body. You may have to prove that you have certain controls in place to validate beyond the systemic guarantees that a system may provide. So what we built out is this, or we're proof of concepting out, is this end-to-end auditability capability at the record level. So using the interceptor APIs on 0.10, injecting logic into the producer and consumers, that all you have to do is configure that nice interceptor classes configuration on the producer and consumers to achieve an end-to-end auditability flow at the message level. So if you look at the bottom right, there's the chart of producer-consumer checksum diff. So you can actually see at the record level, here's the record that producer produced, and here are the records that the consumer consumed. There's a performance penalty you pay for this, obviously, but in this case, again, we're just proof of concept right now. I don't know if influx is the right answer to be the state store for the system long-term. But the way the client works is a lot like the way the Apache Kafka producer works, in that you can batch relatively significantly to reduce the amount of calls you're actually making to the back end. The other thing, so before working in the Kafka world, I came from the sort of RESTful API world in our data movement space in our organization. And one of the things that that world got right was the Swagger specification and the developer portal. So we've created, in the Kafka world, a sort of Swagger specification for Kafka. It's just a JSON object that defines configuration about the topic, and then some metadata about the topic, so our message is keyed, who owns it, what do we anticipate throughput's going to be. Then on top of that, we've built what we call our operations portal, where you can go, and because we have thousands of topics across our environment, and discover data, or discover, here are the topics that are on any given clusters, here's how I connect, here are the endpoints. And then also through this interface, you can go and request a new topic. So the way we provision topics is by making a pull request against a GitHub repo that has all of those JSON objects. And on merge, we have some scripts in place that will go out and provision that topic on the cluster. So taking those concepts that we learned through the sort of RESTful API world and applying it to the Kafka world. And there's a final interesting use case we're looking at right now. So if you look at a typical, so this is getting out of the business event messaging and into this sort of log aggregation and analysis space. If you look at the typical log aggregation stack deployed in the cloud, you have some servers out there that create logs. They are shipping logs to a Kafka cluster. That Kafka cluster has a series of forwarders reading off of it. Think like Logstash forwarders, let's say. They are writing those logs into Elasticsearch, where a fraction of a percentage of those logs are actually queried at any given time. Now, let's say you have 8 terabytes of data a day moving through that pipeline, and each of those prospective hops has components that reside across availability zones at a given cloud provider. That's a lot of data moving, and that's a lot of money, especially when you're doing low latency persistence to SSDs, to provide a quick search function. So what we started to think is, what if we could query the log stream directly from Kafka as easily as we could, or as easy as we do from Elastic today through Kibana. Now this is still, I would call this like pre-alpha level software, but we're working with our high performance computing team to build out what they've dubbed Thalamus, which is a Kibana-like UI built directly on top of Kafka. So you just ship logs to your Kafka cluster, and then they become searchable directly from the stream. Now there are some gaps, especially in this initial one, because when I inject a query into the system, I'm injecting it now and only seeing what's happened in the future. We don't yet, or this initial release won't have the ability to like seek to a timestamp and see what's happened in the past, or if I need to take a snapshot and keep it off to the side for longer term analysis. But it's a really powerful concept that I think has a potential to simplify and save a significant amount of money in what we're spending on our log aggregation and monitoring and telemetry stacks. So thank you. Thanks to the Kafka team at Target. There's a couple of us here, and everyone else who's not here. It is an awesome team, and they do a lot of awesome work. Thank you for coming, and then open it up for questions.
Hi. Are you thinking about open sourcing the last thing you showed?
I don't know.
Please.
I have an opinion I won't share, but I don't know.
I'm actually curious to know how the search works with Thalamus. Like, how does it do the indexing? Like, what's happening behind the scenes there? Thalamus is kind of like almost like Elasticsearch attached to Kafka, right? Isn't it? Is that how I understood it?
It's not Elasticsearch in the sense that it would be actually persisting that data to disk. It's literally, it takes what I think they're an MQL query, so it's a SQL-like syntax, compiles it down to like real-time compilation down to, think of like a streams API they're using. So it takes the SQL-like syntax, compiles it real-time down to a C library that has filtering and aggregations and those sorts of mechanisms built into it, and injects that to start that process real-time.
Just a quick question. When you turned on security with SSL, did you notice a significant performance degradation?
Yes. Well, I should say that. We turned it on, and then over time, after we turned it on, we started to see a couple of things that we shouldn't have seen at the volumes we were running at. One was a thrashing in under-replicated partitions. So we saw this odd behavior where, and there was no rhyme to it. It was under-replicated would spike for a minute on a given top partition, node in the cluster, go down. And this just happened, and as load increased, it continued to happen more. And the other interesting thing was the network processor threads on the cluster. We're doing the same thing, and those under-replicateds sure correlated with those network processor threads. And we saw these two groupings of network processor threads. You had this grouping all at 100% available. Those were the plain text ones. And then all those thrashing around, thrashing from 80, 90% available to 0% available, those were the SSL ones. And so it took us, I mean, we hit a tipping point one day, and it was a 72-hour endeavor with little sleep and little food. But we eventually found out that the root cause, and I hope I explained this right, but there is a shared resource across the cluster. It's the secure random instance, has a global lock. I think it's on the implement next bytes on the pseudo-random number generator used by default on Linux. So essentially, you have this globally locked resource what we first initially said is, why don't we increase the number of the number of network threads to try to relieve pressure? That didn't help. It actually created more contention on that lock. But eventually, we found that out. And there's a fix in .10 for that. There's a configuration where you can change what the random number generator you're using is. We were on 9 at the time, and I think we overrode it at the JVM level as a JVM option for the time being. So that was a long way to say, yes, we've experienced performance issues with SSL on, and that was the reason we experienced them. Since we fixed that, capacity is where you would expect. I mean, we can now do hundreds of thousands. At the time, we were doing tens of thousands of messages a second. Now we're doing hundreds of thousands, millions of messages a second on the clusters without issue.
So speaking of performance issues, you mentioned earlier about the fetch min bytes equals 0 setting.
Yes.
So why does the library act that way when it's set that way? Is there some advantage? Is there some reason you would want it to just spam the server when there's nothing coming in? It seems a little unintuitive.
I don't understand why anyone would set it to 0. I don't think there's a logical reason for that. I mean, even 1 is pretty aggressive, unless if you really are latency sensitive, yeah. But I don't know. I personally can't think of a reason you would need to set it to 0. Yeah.
Hi, thanks for the talk.
Yeah.
So can you give us a little bit more detail about the the stores cluster, and is it just a matter of like restricting the topics that are consumed that way to those clusters, or is there anything else?
Yeah,
that you need
it's
to do?
more, so the guidelines we have for when that cluster should and should not be used are more around whenever there's a potential for that multiplier of producers and consumers to be there. So let's say we have an item change topic that resides on our enterprise cluster that's capturing item changes from the item system. Let's say stores happen to care about those item changes, and let's say all of them do. In that case, we would mirror that topic over to the stores cluster, and they would consume from there after we mirrored it over. And if they're all, let's say for some reason they're producing price or item changes themselves, and there's a topic that wants that information on our enterprise cluster, they would produce to the stores cluster. We'd mirror those over to the enterprise one, just to isolate, because I believe they happen to be one of those that had the fetch min byte set to 0 problem for a while. So whenever there's something like that and you have that multiplier, we just isolate it for that reason.